To get the most out of your Link 6 system, there are a few tips and tricks in this video that can help you increase efficiency and maximize the usability of your robot. Our first tip relates to non-blocking tiles. A non-blocking tile works like any other tile. The difference is that your program can proceed to the subsequent tile before the action of the non-blocking tile is completed. Not all tiles can be set as non-blocking. Only certain tile types, like the Set Output tile of the Industrial I/O plugin, can be set. Tiles can be configured as non-blocking by clicking the checkbox on the top right corner of the tile configuration pane. By using non-blocking tiles, the controller can perform multiple tasks at the same time, which can help reduce the cycle time of your applications. Our next tips are about matrices and program variables. The matrix tile is a robot tile in the programming interface. You can use the matrix tool to generate Cartesian coordinates on a regular grid. With the grid approach, you can define a large number of regularly spaced poses with just a few inputs, rather than creating them all individually. This is useful when your robot needs to interact with objects on a grid. First, define your matrix by entering the number of rows, columns, and layers it has. Then, define the position of the corners. The controller will generate poses that are evenly spaced on the grid you've created once you run your program. Instead of typing in the positions by hand, you can also use the Update button to use the current pose of the robot. After that, click the icon to select an output variable to store the values to reuse them in your program. Program variables are useful to share data among tiles. When configuring a tile, fields accompanied by this icon can have values that are defined by variables. You can use the basic set tile to change variables at any point in your program. For example, the output value of a read input tile can be used to enter a condition, or a matrix output variable can be used to define waypoints in a loop to go over multiple positions on a grid. We recommend keeping a clear separation between program and persistent variables for ease of reference and to avoid error. Let's talk a bit about persistent variables. By accessing the Variable Manager through the main menu, you can create persistent variables, which can be accessed by all programs on the controller. These variables are useful to define frequently used values, such as a safe home position that can be used to initialize any program. Another useful function of persistent variables is to store coordinates for custom frames associated with tasks. By defining multiple waypoints using a single custom frame, you can change all their absolute positions at the same time without changing their relative position. All you need to do is modify the variable used to define the frame. A single custom frame can be defined for a waypoint tile by clicking the Custom Frame tab in the Tile Configuration pane. You can configure an individual waypoint to be defined relative to your custom frame simply by selecting the custom frame in the Reference Frame drop-down menu. Custom frames are useful when the position of the robot is subject to small changes between uses. Experiment with these tips and tricks, and you'll soon have a robot that is both more efficient and convenient to command.